So the final lesson for this unit is determining missing values and also line plots. So our objectives are to determine a missing value from a data set and to create a line plot. So we're going to go through two examples of finding the missing value and one example of a line plot. We're going to start with a golfer who wants an average of 88. So far he's shot 88, 90, 86, 89, 96, and 85. So we're wondering, what does his next round need to be so he can reach his goal? So we're looking at an average. Remember, when we find the average, we add all of the data values and divide by total number of data values. So we have 88, adding all of the data values, plus this one additional unknown data value, his next round of golf, divided by total number of data values. Well, so far he's played 6 rounds of golf. When we add on his next round, we will now have 7 data values, and he wants his average to be 88. So we start by canceling this division by 7, multiplying both sides by 7, we get 616. And simplifying, adding all of his rounds of golf together so far, we get 534 plus his unknown round of golf. So when we subtract 534 from both sides, it turns out he needs to shoot a round of 82 in order to reach his goal. We're going to look through that one more time, since this is kind of a challenging topic. So again, it's similar. We have these different test scores, and this person wants an average of 80%. So we start by adding up all of the data values, or the test scores she's earned so far, plus her next test score, divided by, and once again she's taken 6 tests, but once we add on her next test, she'll have taken 7 tests at that point, and she wants her average to be 80. So I'm going to show a little more work on this one. So we cancel our 7 in the denominator by multiplying both sides by 7. So we get 560. And simplifying, adding all of her data values together so far, her test scores, she has a total of 460. Sorry, that's an X. And solving for what she needs for her next test score, when we subtract that 460 from both sides, she needs to score 100% on her 7th test in order to average 80% overall. And finally, line plots. So we've got number of TVs per household. What a line plot looks like is a plot on a number line. And line plots are good when you have all of your data values are repeating. So if you look, we have more than 1 1, more than 1 2, more than 1 3, etc. So we're going to start by just plotting our data values, try and space them out evenly. And then you just put an X above each one. So you don't need your numbers in order to create your line plot. Similar to the stem and leaf plot, all of your first row of X's you want to line up together. All of your second rows you want to line up together, and so on. 2 5s, 4. And you want all of your X's to be about the same size. Alright, so that's what our line plot looks like for our data set. And then the last question, we're going to take a look at analyzing our line plot. How can you determine the mean and median from the graph? Well, if you take a look at your graph, the 1s and the 5s have the same amount of data. The 2s and the 4s have the same amount of data. So our median has to be somewhere in the 3s range. And same for the mean. Because the data is symmetric, that 3 is the tallest and it's equal on both sides, the mean would be the same. So how can you determine the graph is symmetric? So if the graph is not symmetric, you would look at where the data is really heavy for finding your median, and you may have to just calculate the mean by hand if the data set is skewed.